Hello, everybody. This is Brian David Johnson, the guest editor of the IEEE Computer Magazine's special issue on the world of making. To pull together the contributors for the world of making, we really looked to lots of different viewpoints and lots of different inputs. We went and looked at people who were doing work in biology, or people doing work in design or science or business or technology. We looked at people who worked in entertainment, also education, or people who were concerned even broadly with culture in general. And the goal for this was to go and cast a very wide net to get a snapshot, a global snapshot of making in 2014, and to bring that back together. And today on the podcast, we have the St. Ledgers. I'm very excited that the St. Ledgers have joined us. Now, I've worked and been around with the St. Ledgers for quite some time. It's Jim and Skylar St. Ledger. You're joining us today on the podcast. Gentlemen, thank you so much for joining us.
Great to be here.
Thank you.
Now, I've been at several events, both with Jim and Skylar, and it should be said that Jim and I work together at the Intel Corporation. So before we start diving into this notion that you guys have of making the next Gengineers and your article, let's get a little bit of background. Can you give the listeners a little bit of background for the both of you, and also how you came to making, how you came to be a part of the world of making?
Yeah, this is Jim. I'll start off. Just a quick snapshot of myself. I'm on the very tail end of the baby boomer generation. So I went to school back when they still had shop class in school. For those kids who are like, what's shop class? That's just how old I am. My background educationally is a bachelor's in mechanical engineering. I went to RPI or Rensselaer, and then I got a dual master's in business and engineering from Northwestern along the way. My career largely spans a couple of vectors. I spent a big chunk of it in automotive in the very beginning, switched to aerospace, maybe midway. Then I made a third transition into the field I'll generically call semiconductors, both on the fab equipment side and also on the business product side, which is where I live today. Currently managing, I joke, I'm a mechanical engineer who's currently managing a large software program. So that just, I guess, speaks to how careers morph these days. My sort of introduction to making, I guess if I have to look at it, I'd point it back to when I was a very young kid, really interested in how things worked. Taking things apart, collecting parts and building whatever I could. And then as I got older, it expanded into, bigger tools, bigger projects. And then I'd say more recently, Skylar is the oldest of our three kids. And that's sort of given me, let's call it a whole new experience and exposure to making as it is in the late 20th or 21st century specifically. Skylar?
So I'm 14 years old. I'm in 9th grade. I do software and hardware stuff. I'm on a FIRST Robotics team. I do FRC, FIRST Robotics Competition. I've recently been doing a lot of software work. I also do work with 3D printing, and I like to build things. Yeah.
SDR.
What was it like, Skylar? Because you've pretty much grown up making. You've kind of done lots of projects. I've seen a lot of your projects. What's that been like? What was it like to grow up making?
Well, typically when I see a problem, I don't first look to who else can fix it for me. I instead look to how can I fix this. There's also an element of trying to see how things work and take things apart too. One of the big things is I like to take things apart, see how they work, and learn from what other people have done.
Mm-hmm. And so, as you were thinking about pulling together your piece, and I have a couple questions actually when it comes to the article. So, Jim, we'll start with you. When you were thinking about this notion of making the next Gengineers, what were you trying to capture? I mean, I think you've learned quite a lot as you move through the world of making, and also just move through the world of technology and actually being paid to make stuff as well. what did you want to capture in the article?
Yeah, for me, it's a couple things. One is, I think, somewhere along the way, I think, at least in the States, right, we've lost a lot of the interest and focus, at least from let's call it a K-12 educational level, and I think even to a large degree the undergraduate level, of hands-on skills around making things. We've sort of taken the approach that, well, if you're college-bound, you're going to focus on textbooks and problems and calculus, and then you get into school and you'll do mechanics and physics and things like that. But you don't, outside of labs, you don't necessarily get, quote unquote, get your hands dirty and get the tools out. And for me, this emergence of making as sort of an overall philosophy and methodology, to enable STEM is probably one of the biggest things in educational circles. I couldn't be more pleased to see it. I'm a huge fan and proponent of it. When I see it pop up at local clubs, local makerspaces, Boy Scout troops engaging it, Girl Scout troops engaging it, robotics competitions, libraries bringing out makerspaces. For me, these are fabulous trends that I'm trying to foster and spread. Once you catalyze them a little bit, they seem to take on a life of their own and take off. Because I think people really have the making spirit in them. They're just looking for an opportunity to get it out and practice it. And I just wanted to expose that a little bit more, through the IEEE medium, and hopefully spread that word a little bit further.
But also one of the things that I've been struck with is it's very personal, right? That you've really seen that making has changed your life and changed your family's life, and has the potential to change people on a very personal basis.
Yeah, I think, what I've shared in my story is kind of our personal family, our family adventure, if I'll call it that. And there's additional stories that continue as my other two kids grow up. And as I was thinking about it, there's a story of when my daughter, who's currently 10, her first trip to Maker Faire, Bay Area, which was, a few years after Skylar and I had already been going. And I wasn't sure how she was going to embrace it. To be honest, I wasn't sure whether she'd have a great time or leave saying, that's 2 days of boring stuff I'm not interested in. To my tremendous pleasure, she completely took to it. She went from having never really played with electronics to learning how to solder, including burning her hand, which became part of the adventure and family folklore, and her younger brother is the same way. And now every year, as we start rolling around the calendar towards the end of the school year and towards May, they're all already talking about, hey, can we spend more time at Maker Faire? And in fact, this past summer for our sabbatical, we went to Maker Faire Paris, and the kids all had a fabulous time there. So what that showed me really is that I'll call it the most unsuspecting children can take to making in ways you'll never expect. And that's something I've seen over and over in my own family, in my friendship circles. I have somebody at work whose family is more, let's call it sports and athletics related. And of their kids, if you have more than one kid, every kid is different, very different, right? And their mom came to me and said, hey, we think our kid's more into like robotic stuff, but we don't know where to start. So I actually connected them with my youngest son who's doing some Lego Mindstorms programming, and those two kids completely hit it off, right? And as a parent, they're just looking for a way to find things to engage their child. And I think making has a tremendous potential for that for almost any child.
So Skylar, what's it been like to have your little brother and your little sister now getting interested in making? What's that been like for you?
It's been interesting. They've asked me for help with stuff, and actually one of the things recently they've done is, I'm not sure if you're familiar with the Nerf guns, they shoot foam darts, but apparently there's this whole thing online about modifying them. So one of the things that they recently started doing was actually modifying their Nerf guns to work better. I don't really do it, so I'm not entirely familiar with it all, but I think one of the things is, while making is a very broad term, two different people may be interested in making many different things, because they've asked me for some help with things. I mostly just give them guidance and advice on how I see different things working. but they're definitely starting to make more things now.
I have to jump in with a little personal story. So the Nerf element of making is really interesting. So if your kids aren't into Nerf guns, I don't know as a parent that I recommend it because they seem to be very contagious but an awful lot of fun. And what I've found is that, there's this whole, I'll call it a sub-community to some degree. If you go to YouTube and search on Nerf guns, there's all kinds of videos on using them and, of course, hacking them. And so what I found my two youngest kids doing, and they do this with other kids in the neighborhood, it's actually almost scientific experiments in engineering. So they go outside and they go out in the street with a tape measure and they fire the gun at different angles to see how far these little foam darts will go. And then they go inside and find some hack online to the particular gun they have, and they pull out air restrictors and they put different springs in it, and then they go back out front and see if it'll shoot even farther. And, for engineers listening to this, this is exactly, it's not quite design of experiments, but it's engineering experimentation for product improvement, right? And they're doing it as,
or
7,
if you
8,
want
9,
the
10-year-olds.
new fancy term for it, evidence-based engineering.
So there you go, right? But this is where kids embrace things that in educational circles we label STEM. You don't need to call it STEM for a kid. You just need to find something that they can latch onto and really have a lot of fun and then be learning those things even though they don't really know it.
And this actually, one of the other things that this brings up is FIRST Robotics. FIRST is an acronym. It stands for Inspiration and Recognition of Science and Technology. And one of the cool things about FIRST is it's like this, but it takes this to a very practical thing where every year there's a challenge and you design and build a robot to compete in a competition to solve that, or to compete in a competition in that challenge. And one of the cool things about it is when you do it, you don't learn all the engineering, design, practice rules instead. Instead, what you learn is you'll have a team, you'll have the students, and then you'll have a few mentors. And the students will come up with ideas, and then on our team, the mentors will give us feedback. So it's really great that we learn from engineers who have a degree and know what works and what doesn't work, and then we can work with them to learn what we should do and what design practices are good and bad. But it's not learning as you get homework and you do stuff. It's actually very fun. And actually, FIRST has been called the hardest fun you'll ever have.
Well, my last question for you is, where does all this lead? I mean, obviously in the title of your piece you did for the IEEE magazine is that it is about the next generation. It is about sort of coming up with the next generation of engineers and scientists and creators and thinkers and tinkerers. Where do you see all this go? If people begin to embrace making, embrace a little bit of fun, embrace this sort of hands-on learning, what do you think is the potential? Where do you think it can go?
So for me, where I think it can go and where I hope it's going to go is really to put some more excitement into the earliest years of people heading down an engineering path or potentially heading down an engineering path. I do a fair bit of mentoring today, and what I hear from kids continuously, the ones who even make it into like their first year of engineering school at a college level, is sort of this element of boredom at having to do all these core subjects, right? Because we sort of hold them back too long till they get to the interesting stuff, and some of them don't make it. I think the earlier you can get them excited about engineering from a hands-on perspective, to where, like Skylar said, right, the most fun you'll ever have or the hardest fun you'll ever have, right, like FIRST claims, that's really going to plant the seed that then as they continue down this path of, hands-on invention and making, I think that will get kids to see that engineering can be an awesome career and really get excited about it and then pursue it, even through some of the hardest moments, right? We've all had, everybody's got the tough courses they maybe don't want to do but have to do to get in pursuit of that degree that gets you to your first job. And I think having some of these hands-on skill opportunities really goes a long way to keeping the personal momentum in kids. Skylar, what do you think?
I see it as, what I'd like to see is that engineering becomes more fun, and maybe in middle school and high school, or middle school and elementary school, you have your science and math and history and English, but you also have your engineering class, your making class, where you learn about these things or you do these projects, or instead you have one class where you learn all of these things and it's done through making projects. Because what I see now in school is you have science, math, English, and history, but they aren't really that well connected together. And if you're lucky, you maybe get a science teacher who will teach you the math and how it works, but there's not that much of an integration. This is where I think STEM and STEAM, or TEAMS as you called it in your article, will really help to teach students practical applications for things. Because one of the things that I've seen a lot in math is I learned something, but I don't know a practical application for how can I use this.
I think back to my first calculus class. I remember one of my buddies said, when the heck am I ever going to use this stuff? And I think that's one of the problems is if you can't see a connection at all between what you're studying and where you think you're going to go, you're just not going to put the same effort into it. I think if mentors and teachers and parents can help kids see the linkages, between something as simple as changing a spring in a Nerf gun. Hey, let's talk about a spring. And this is, you squeeze it, it's stored energy, and the size and shape of the spring makes a difference, and you can make some calculations to do that based on some spring constants. Then all of a sudden, you incrementally get kids to see things, and the light bulbs eventually start going off in their heads. I think it'll make for a world of unbelievably creative engineers in our future.
Yeah, I agree. So listen, Jim and Skylar, if anybody wants to get in touch with you or contact you or find out more information, where should they go?
Well, so you can start on Twitter. We're both on Twitter, and we'll give you our Twitter handles and our email addresses. I'm on Twitter at Intel_Jim.
I'm at Twitter at DocProfSky. You can also contact, there's my email, and that's skylar.st.ledger@gmail.com.
You want to spell Skylar for him?
It's SCHUILER.ST.LEG as in giraffe, ER @gmail.com. I deal with people misspelling my name frequently. You can also find me on GitHub, which is github.com/DocProfSky, DocProfSky. And it's there, my email is listed, and I think my Twitter may be listed there too. On GitHub, I have all the software that I've done.
And if you want to send me an email, it's jim.st.leger@intel.com.
That's great. Thanks, guys. And we'll provide all the links to all the listeners as well. Listen, Jim and Skylar, I always love hanging out with the St. Ledgers. You guys are great. I think that also your article really just stood out because I think it can show not only how making and this type of thinking and just this robust curiosity for building things and making things, and as Skylar says, don't be afraid to break things, that it can not only be transformative for the next generation of engineers, but it can also be transformative for a family. And I think that the story that you guys told was very personal, and I really thank you for that. And I also thank you for joining me on the podcast today. Thank you guys very much.
It's our pleasure. Thanks.
Thank you.